Do you guys remember adding, subtracting, multiplying, dividing rational expressions?
No.
Nope.
It's when they're like really big fractions. They kind of look monstrous, like x minus 1, and on the bottom you have x plus 3, and you have to add it to something like x minus 5 with the 2 on top. And you had to find common denominators and then add them together. You guys remember doing stuff like that? Well, hey, we're not doing that. We're instead going backwards. We're going to take this answer right here and find out what we had to add together to get that.
Why would you do
Don't say, oh, this is cool. I heard a great question. Why would you use such a thing? Why would you do that? And I'm going to tell you, the reason why you would do that, because in the real world, when we apply mathematics, they would do that in order to analyze a function more in detail. And so today, I will show you how to do that. And it's kind of cool because it reviews a lot of concepts within it, and at the same time, we're learning something new. So, pretty much what we're doing is this. We're going to take this x minus 7 over x squared minus x minus 6, and we're going to find out what two fractions would add together to give me that. Now, this is how we set it up. So this is going to be our answer right here. What you do first is we have to find the factored form of the denominator. In order to find the factored form of the denominator, you can use big X or whatever kind of method you like to use, and you would get negative 3 and positive 2. Once you have all of your factors, those go on the denominators of your partial fractions, or the fractions that you're trying to find. So we have x plus 3 and x minus 2. So far, so good. Next, what we need to do is we need to find what the a is and what the b is. So, in order to do this, let's copy all that stuff right here so I can work with it. X minus 7 over x squared minus x minus 6 equals a over x minus 3. And we have plus b over x plus 2. In order to do this, the first thing we're going to do is get rid of all these ugly fractions. So to get rid of all these ugly fractions, most of you guys know, to do that, you have to multiply everything by the lowest common denominator. So what I'm going to multiply everything by is x minus 3 times x plus 2. Multiply everything by this. And so when I multiply this times this, it's actually the one that's the fastest out of all of them, because x minus 7 over x squared minus x minus 6 times x minus 3 x plus 2 over 1, so that's what this is. This is over 1. These would just cancel out because they're the same. If I actually multiply this out, it would be the same as this. So because they just cancel out, you're left with x minus 7. But what would I get on the other side? We'd have to take this and multiply it to that fraction and to that fraction. So to multiply it to the first fraction, the a fraction, it would look like, let's see, a over x minus 3. Put parentheses around it because it looks better that way. X minus 3, parentheses around that dude, x plus 2 over 1. These would cancel out, right? Using, cross-canceling, cross-simplifying. I can't remember the word right now. But then we have 1 times 1 on the bottom, which we don't care about. We don't care about 1 being on the denominator. And then we have a times x plus 2 on the top. And so we're left with a times x plus 2. Out that way. Let's write this right here in factored form. X minus 3 and x plus 2. Okay, this one's x minus 3 and that one's x plus 2. That's how I knew that this was the lowest common denominator. And instead of changing them all, which you can do, you can just find the lowest common denominator and make them all have the same denominator. You're going to get the same result as I'm getting right now. This is kind of a shortcut way of getting to it. By just multiplying everything by the lowest common denominator, and then we won't have any more fraction. Alright, so I multiplied to the a fraction. Now to multiply to the b fraction, let's see, let's give myself some room down here. To multiply to the b fraction, one of the factors will be canceled out again, just kind of like what happened with the a. it would look like this. B. And this is all work that I'm writing right now. This is work that you would kind of start doing in your head once you start understanding it. X minus 3, x plus 2. Okay, if I was multiplying this times this, it would look like this. What would I cancel out here?
The x plus 2.
Yeah, cancel out the x plus 2's, and I'm left with b times the x minus 3. And so you get b times x minus 3. So, remember that our whole purpose here is to find the a and b are. The problem with our equation is that there's 3 variables in it. We have x's, we have an a, and we have a b. You can't have 3 variables and solve for one of them. You can only have one variable, unless you have 3 equations to have a system of equations, but that would be kind of obnoxious. Let's just try something here. Now, in functions, or in expressions, x can be whatever we want it to be. This is for all real numbers right now. Actually, we can't plug in certain numbers. What numbers can we not plug into this?
3.
We can't plug in 3, we can't plug in -2, because that would make it undefined. But actually, we can use those to eliminate our x's and eliminate one of the variables. What if I said we can let x equal -2? What would happen? Let's see. I plug it in there. And let's see, I got this. And then it would be, I plug it into that x. If I plug in -2, what would happen? Will I be left with one variable?
You'll be left with 2.
Let's see. If I plug in -2, I plug it in right here. I would plug it in right here. And I plug it in right here. What happens? Well, this right here becomes 0, right? -2 plus 2 becomes 0, so I have 0 times a. What's 0 times a?
0.
0. And so I'm left with, let's see, that's -8? No, 9. Equals b times -5. No, I think I did something wrong. Let's try to find my mistake. Sorry, guys. I know what this is supposed to look like, and it doesn't look like this. And look, you have to change this. You guys ready?
No.
You have to change this minus sign to a plus sign.
Me?
Oh, come on. That's not that bad. Just change it to a plus sign. Oh, my goodness. I can't function. Just change it.
Wait, which one?
You've ruined my day.
X minus 7?
All right, so now that that's fixed, this becomes 5. All right, so I divide both sides by -5. Look, a pretty answer for a pretty example. Not all things are pretty, though. So my b is -1. Now, because it's negative, you could, instead of writing it like this, you could put a minus sign right here and make that a positive one. Both sides, both ways of writing it are good. Just know that, like, if it was multiple choice, you'd probably see it like this. It'd be a positive one right there, and it'd say minus because it's a negative. All right, so now let's find the a. Now the cool part is, to find the a, it's kind of the same thing. What we're going to do is we're going to pick a number so that the b gets eliminated, so we can find the other. So we can find the other variable, the a. So what would I plug in so that the b gets eliminated? 3. So I plug in a 3 to all my x's, and I get 10 equals a times 5. And the b gets eliminated because 3 and -3 is 0. 0 times b is nothing. So what does my a equal? It equals 2. And there you have it, students. There's my answer. Right there. That's partial fraction decomposition. Now I want to do something kind of interesting with this. I wanted to show you guys what the graphs look like.
Yeah.
You see this graph right here, the black one?
Yeah.
The black graph is the main function that we just broke apart. This is the x plus 7 over x squared minus x minus 6. And then you see the green lines? And you see the blue one? You can barely see the blue one over here. Those are the 2 partial fractions that we split it up into. And you can kind of see it better like this. Here's the blue one. And here's the green one. Isn't that kind of interesting though how they kind of wrap around the function that the equation or expression that we just split up. This is them all together, all highlighted and stuff. The black one you can barely see right here because the blue is so much like it. But they share the same asymptotes. That's kind of interesting. But they would use, I mean, the whole reason why we're doing this is because it's a very applicable thing when you get into some kind of job that uses rational expressions. Well, hey guys, the only people that are doing stuff like this at jobs are the ones that get paid the most. So it's good to know like where you gotta be if you want to get paid the most. You want to get paid the most, you have to understand the mathematics, the way everything works. Trust me, those are the people that make the most money.